Hello, welcome everyone for 17th session, Enterprise Artificial Intelligence. We've been interacting good stuff related to machine learning and big data engineering. Harun is helping you understand handling the batch, handling the real-time data with Spark data types, data structures, RDD, and its transformations and its operations. And you started seeing its importance in the machine learning, where you understood machine learning follows a basic process. Any machine learning process, any machine learning model building or any machine learning project has a common process which can work as a guiding principle for all of us, where you get data, clean and prepare data, manipulate data, train the model, test with that, and improve. So with this, you may be able to build models and improve the models and can work with other software engineers or other teams where you can deploy these models into applications. It depends on what type of applications your company is building. So that comes as a pure software engineering, so you don't have to worry. There will be a lot of people working with you, but most of your time goes to actually first and second itself. Definitely third and fourth is the one where you need a lot of knowledge. First and second is more programming, cleanup, understanding what transformations you need to do. Your big data engineering helps on it. 3 and 4 is all about understanding the models, building pipelines, and getting the predictions, getting the validations, etc. Fifth is the last step, and it is an ongoing step. It is a never-ending steps, but you don't have to worry much. Where you can nowadays there are a lot of automation going on, and you already seen building parameter grid. You can do a lot of automation. Anyway, quickly connect with our friends. Few people are going to dial in a little bit late. We are going to enter into a next stage where all of you are going to participate in giving presentations, which would help you to prepare, which would help you to present, which would help you to collaborate with me, Harun, and with all of the team. So I encourage you to participate in this last leg, maybe another 4 or 5 weeks. So then you may be able to get ready for the market. So let's understand for who all there. We have Leela and Mukesh. Welcome, Leela and Mukesh. How are you guys doing today? And you want to greet our friends?
Hi, Srini. Hi, all. Thank you today.
Welcome. Hey, Mukesh, how is going with you? Mukesh might be on mute. We have Narayan Rao from India. Hey, Narayan Rao, how are you doing today?
Hi, Srini. I'm doing good. Hello, everyone. Thank you.
Excellent. Narayan Rao, welcome. We have Sairam, who is going to be in action in the next 2 weeks. Tomorrow he is going to present a good stuff but small stuff. Next week you will have more action. So Sairam, welcome. How are you doing today? You want to greet our friends?
Yes, doing fine. Good morning, guys. Hope everyone is doing well.
Excellent. Welcome. We have, okay, Leela, we already talked. Okay, Hema is going to dial in after some time. A few more might join late, or they might want to use the record. Harun, how are you, sir? Are you there? You are mute. You want to
Yeah,
get
hi
up?
Srini. Good morning. Good morning, everyone.
Excellent. Awesome.
Great.
Okay. So, okay, guys, everyone, please focus, please participate. So, as I mentioned, it is you who should participate from now onwards. This will take you to the next level so that you can handle the discussions with people very well. As I mentioned before, these are very powerful computer science techniques that are changing the world, and we are only in the beginning. But at the same time, it is very well matured, and everyone is hiring. Everyone is hiring. So if you can articulate, if you can present what all we discussed, I'm very, very confident there will be someone who likes you and take you to part of their team. Not because you need a job. No, most of you have jobs. Because these tools are powerful to solve the problems. So you can solve companies' problems. You solve big problems, automatically there is a growth. So focus on it. We are all there with you. So we have designed this course very intelligently, very aggressively, but at the same time without making you overwhelmed. Certain level of fuzziness or uncertainty is very common in any learning. That too when you are learning very aggressively. But we have a process. We have a process of iteration and interconnectedness that would help you to overcome that fuzziness. So things will come into clarity. I like this quote: all things are difficult before they are easy. So it is a very, very natural. We feel, hey, it's difficult, but things will, or things are, I think already things are becoming easy for you. But you just have to put some effort. I don't say too hard work. I don't even totally believe in too much hard work. I believe in smart work. I believe in work with fun. So we worked a lot in Apple, working with our team, Harish, Hema, Arun, we were our colleagues. We worked hard. We worked very well. Sairam and me, we worked in a big upgrade project. I worked with Siva on projects in Apple. We all did a very good work. But I don't say it's hard work. You know, we have a lot of fun and a lot of discussions. Harish, what do you think? Siva, did we work too hard and broke ourselves?
No, Srini. It was always a balanced one.
Nice. That will. Now Siva is using a very balanced words. I think after we done the project, we got married. Then he understood what his life is. I'm muting everyone, so I see some background. Let me, very good. Okay, guys. So, but at the same time, have some time for learning, not just today, next 10 to 20 years. Learn something continuously, something exciting, something cutting edge, something which is adding a lot of value for the companies. Continuously learn. You find it interesting. If you are not motivated, connected with people who are already working on it. Connect with people who are already exploring this continuously. As you might have seen, this is our 4th year running big data, big data related trainings. Of course, first year in artificial intelligence, machine learning. You might have seen, we're continuously doing. So how do you think we are motivated to do this type of things? What do you think? It sounds for you a lot of hard work. Honestly, it is not hard work. It is a smart work. So it's very simple. We know this is the direction market is going. We know these technologies have high importance in every company, almost every company, which has high demand. So we know that. That is what, based on our reading of the market, based on our research, based on our discussions with people. So that is where, so I laid down the path. So some of you believed, as you interacted with me, like Harun and few of Vijay and few others, and now you are working with me. And they have seen it's a long path. It's not easy path, but it works. It works. So 3-4 years in America goes very quickly, you know. It goes very quickly. Even your friends, you might have met them 5 years back, 10 years back. It goes very quickly. So whether you do good work or not, the time will pass. So that's where I really encourage you to collaborate with the team. You may not be too excited for every class, but as you meet people, as you discuss with the team, as you take up something to present, things start becoming interesting. So already the goal is fixed. The goal is a good path. The goal is all of you are going to have excellent career. There is at least 20 to 30% compensation differences between artificial intelligence people, machine learning teams, and regular software people. So coupling with big data, having machine learning will put you in a very good position, very good position. So then we are also adding deep learning and natural language processing. So to summarize, I encourage everyone to focus on machine learning and big data first and build a career out of it. The deep learning and natural language processing, put it as a reference. Understand and communicate with people that you know this. You don't have to do a lot of hands-on for deep learning and natural language processing. Keep it with you. But and consolidate machine learning and big data until you take up a couple of projects. So what I'm telling you, the summary, start focusing, start practicing on what all you have learned in the class till now. first do just repeat what we have done in the class. I will work with you to start giving presentations. I'll share the slides. Let's go here. We already have. Let me move this. This is the teams we have. This is the models we are trying to address. Regression problems, you all know. You may have data, you need to predict. So basically you are predicting a line, straight line. A straight line is nothing but weights and intercept. In the clustering models, where you cluster the data, classification is very, very important, which has multiple models we have seen. Logistic regression, decision trees, random forests. Interestingly, we have one more, which is called gradient boosters, where you can boost the trees. And there is one more called naive Bayes. I will address it in one of the classes. Right now, don't worry about it. So classification has a lot of importance in the industry. And of course, and the recommendations is very much useful for the customer-centric applications. So here we have Hari, DK, and Narayana. Hari, DK, and Narayana from India. DK is a little busy. He is coming back to US next week, but he will join after some time. So right now, Hari, I encourage you and Narayana to collaborate. So you guys have to present in 2 weeks. You guys have to present in 2 weeks. Not next week, following week. Focus on this. I'll work with you.
Okay.
Okay, get ready. So we have Hari, Hema also joined. Hema, how are you? And Hari, how are you guys doing? You want to greet our friends? Kiran, welcome. Kiran, how are you? You want to greet our friends?
Yeah, Hari here. Hi everyone. I'm doing fine. Hope we have a good session, and then looking forward to more collaboration with everyone. Thank you.
Excellent.
Hi Srini, hi everyone.
Hi, welcome.
Thank you.
Hema, how is going with you? It is all right? Okay. Hold on. Let me see. Okay, give me 1 second. Let me mute everyone. Okay, the session today goes like this. So I'm going to talk a few minutes on a pipeline again. Next, we all have this slide, and we'll discuss why we need to focus on these two, and this keeping a reference. Then we'll review our projects, rather project teams. And we have one use case about customer churn. I'll introduce them so that our team, Sairam, Leela, and Hema will take up for next week. And also, we have Harish, Surya, and Kishore. Their focus area is the recommendations and market basket analysis. So Harish will be presenting something next week. So I'll give roadmap for next 1 month on these teams, about these teams. Okay. Next, after the break, I will introduce the deep learning. In the orientation, I talk a little bit. I'll refresh that idea. then I will highlight the importance of Python and PySpark for deep learning. That's pretty much the agenda for today. Okay. Hari, any questions? Okay, let's go. So, as I mentioned, keep this diagram as the guiding principle for your machine learning. We all seeing last classes. We're building a lot of models, classification models especially. So this is how you are doing, how you are training the model. You are taking the historical data, you are dividing into training set and test data. Before we divide it, you do the features extraction, data cleanup, all those things. Then what you did is, you're passing it to model training and building. You're testing the model. So when you see here, when you get this data in the training, you pass the features and labels, Siva. You do the model building. You do the model building. You get the model out of it actually. See, model training building, you get model out of it. So from the test data, the test data will have labels and features, but when you are testing it, you don't use the label. Already Hema shown that on that day. When we test it, what I mean is when you pass the test data to model, it uses the features only and get the predictions. Then you compare the predictions with the labels. The labels in the test data is used only for the comparison. But to get the predictions, we use features only. Please observe. In the case of test data. Whereas in the case of training data, you need features and labels. So you get the model, though it shows like this, ideally it should be like this. We'll test the predictions. Then, you want to improve it. Then you go back, you fine tune. Again, this cycle continues. You fine tune. Again, you test the data, rather you train the models, test it for another parameter. So this is where you are using parameter grid, because you have to test it for multiple parameters depending upon what parameters you have. In the case of clustering, you have k-means clusters. The k is a variable. In the case of trees, depth is the variable. Even some people use the maximum bins. Or, the error strategy, like you want to use Gini or what you call the entropy. Whatever the different parameters, you don't have to remember. There are a lot of books you can review. You can review our class. You'll slowly gain an understanding about these things. But even if you don't have understanding, you can do trial and error. Give maximum depth this, maximum bin this, use Gini, use entropy, put everything into a parameter grid. So that's what I'm going to talk quickly. So this is nothing but exactly this only in the diagram. I think this will give you a better understanding. That's why I don't use many diagrams. So this should be a guiding diagram for you. This is okay. But look here. So when you are doing parameters, the pipelines really help you, because pipelines can deal the multiple steps. So we have seen the case of a pipeline. You can do fit using the random forest classifier. You can evaluate using the evaluator. You can start improving. Look here, using the train with all the parameters in the grid. Evaluate to find the best model. So in the grid just a placeholders for the parameters. I want depth 4, depth 3, depth 3, 4, 5, 6, 7. Okay, next. Bins, these many bins are entropy and Gini. So like that, the grid is just like an Excel sheet, a placeholder. Since it is in the pipeline, when you say the train, it trains for all the parameters. That is the understanding. Please observe. Then ultimately you get a pipeline fitted model. So in the pipelines, you hear the words called fit. Some people say estimator also, but in the syntactically you will say fit. So estimator. So estimator always gives the models. Then you will see the word called a transformer. Transformer. Transformer means transforming it. Transforming it. See, when you fit on the training data, you get the model. When you apply the model on the test data, you are transforming it to get the predictions. Even when you want to use vector assembler, you are transforming the data frame, adding an additional column. So try to understand the word transform. Transform always to get the predictions, to get additional columns. But the fit or estimation is mainly for the model building. And the evaluator, the third one. First one is fit or estimator. Second one is transformer. Third one is evaluator. Evaluator is mainly evaluating labels and predictions. So evaluator is to know the efficiency of the system, accuracy, how much accuracy it is. So that's it, simple 3 words. Estimator or fit, transformer, and evaluator. All are put in the pipeline. Okay, this we'll be using continuously in our demos. As your team, different teams, Hema, Sairam, Lila, and Hari, Narayan Rao, DK, Siva, Mukesh, Kiran, and we have Harish, Surya, and a friend from India, Kishore. As you present, Harun and I will be guiding you. Did I miss anyone? Did we cover everyone? I hope. Yes. So you all have stuff to play now. So let's understand. So we've been doing this stuff, Arun and me. We are working on this big data. I'll talk about this IoT use case. IoT is a case where you collect the data from all devices. And when the data comes into streaming data, streaming streaming software like Kafka. That's where your role comes into the picture. You start reading it from a Spark stream. So that would highlight the real-time nature of the data, highlight the importance of big data. Of course, batch is also, big data is also very important for batch, because if this huge data, of course, nowadays, everything is a huge data. So handling the data effectively, both batch and streaming using Lambda architecture, I want you to focus. I want you to review what is covered in the class. And we've been focusing on this large-scale machine learning with different models. So please focus on this. So these two, please consolidate to build a career. Then these, keep it as augmented. So whatever we are going to discuss from today and next classes onwards, keep it as a reference. But you guys focus on this. You guys focus on this. We'll be focusing on this to help you. But this is a time for consolidation. I really appreciate you spend almost 8 weeks, 8 weekends, leaving all your personal works. You are focusing this. I appreciate and value your time. But we need to get the fruits out of that effort. Any labor wasted without getting the fruits is not really good. So Mukesh, I'm glad you are coming, but stay continuously in touch with people. Now it is time for you to involve and participate. Maybe small steps. I'll give you some work. Maybe you just have to present 15 minutes.
Sure, Srini. Sure.
Excellent, excellent. Very good. Hema already has shown you by presenting it. Of course, she will continuously do it. Everyone has a role to play. Leela already took a small step to warm up, but she has something for next week, coming week. Get ready, Leela. Sairam started. Tomorrow he's going to present something. Small things. All small things will become big. You see how many videos grown in our YouTube. 16, almost 16 videos. Imagine one by one class, how it adds up. So Sairam has a presentation tomorrow, and next week he is going to present. Okay, so like that, now I'm setting up a roadmap. I will be involving you guys hands-on and giving presentations in this area. So throughout this journey, I and Harun will strongly guide you. Introduce to you small gaps, what you have, so that we consolidate your knowledge, so that you speak fluently with others. As I mentioned, this one, I'm going to introduce and cover, but don't break your heads too much. You just keep it as a reference. Oh, okay, I understand this. This is how it is. This is how it is. You keep it as a reference. So when you talk to people, hey, you are very good at this and you know this. That is a very good selling point. Selling points. Okay. So we are doing regression classifications and recommendations and clustering, different algorithms called. You ask me where you get this one. Till now, we didn't do any statistics. When I go outside, everyone says, hey, data science means statistics. I'm not good at statistics. I'm worried about it. So those are natural questions. Those are natural questions. So very interesting if you understand, my friends. See, we are doing above statistics. If you go here, machine learning, deep learning, and natural processing are above statistics. So You may ask me, first of all, where you get this? Where you get this? So I'm very strong supporter of the what you call context. We can learn things very well if you know the context. Now we know the context of different models because we have seen some real life examples like aeroplanes, delays, cancer cell related. We've seen the data. So interestingly, come here, come back. Kiran, Sairam, everyone please see. When you get the data, when you clean and prepare and manipulate the data, so these two areas, data scientists spend almost more than 60% of their time. First of all, I encourage you to call yourself as a machine learning engineers. Machine learning engineers. Because machine learning is, in fact, one way ahead of this simple data science. People say data science. Data science is very vast. It covers every task, everything related to data. But machine learning is a specific high value model buildings, etc. So, but machine learning and data science go hand in hand. Sometimes they may say, hey, you are a data scientist also. So it depends upon in what context you are, etc. Don't get confused. But now you see the work. As I told you, you're dealing with data, you're doing a cleaning and preparing, manipulating the data. A lot of data engineering is involved. Somebody might call you as a data engineer. Don't fight with him saying I'm a data scientist. It's okay. So this is a lot of data engineering is involved. But interestingly, we haven't shown that. Sometimes they ask you to do a lot of data exploration here. Data exploration. Okay, you did cleaning, you did prepare, you did manipulate data for machine learning. But before you train the models, some people might ask you to construct, rather to give summary statistics here. Summary statistics, exploration, queries, reports. They might ask you to do that. So summary statistics means on some columns, what is the mean? What is the variation? Those things comes into the picture. So as you start presenting it, I will introduce you to that. Those summary statistics, how you find the mean, how you find average. So those things are available in the Spark packages. But first, try to understand those statistics related falls into this area itself. You get the data and clean and prepare and manipulate the data, or simply put, you should know about your data. You should know about your data. Or use the word exploratory analytics. Exploratory analytics. So you're exploring the data. Hey, before you even train the models, hey, what is our average delay of the flight? What is the average delay of the flight? How many unique airlines we have? How many unique airlines we have? What is the maximum delay generally flights have? What is the minimum delay? What is the minimum delay? Still we call it as delay, some 30 minutes or something. How many flights? How many flights were delayed more than 1 hour? How many flights are delayed more than 2 hours in last 6 years? So like that, you do queries. Those are SQLs. Those are SQLs. So doing those SQLs is nothing but exploratory analytics. So you're exploring the data. You're exploring the data. So try to understand. So that is where we didn't do much of that, of course. We didn't much of that. We've been doing that in the first class. Harun is already helping you, creating data frame, creating what you called from JSON, reading from JSON, etc. And since all of you worked in PeopleSoft and somewhere in testing and different, everyone knows you write the SQLs. And Bukesh already working in general analytics. They do a lot of exploratory things. So if you include that also into this pipeline, then you are covering a lot of data science. Sometimes, 60 to 70% of time people might spend in this itself. So getting data, cleaning it up, exploratory analysis. So I will involve some of you, and I'll involve Harun, and even I will be helping you on this in parallel as you start giving the presentations. So I want to highlight that so that you don't get surprised about this, because you hear these words, in data science, you do some statistics, but you are doing beyond it, model building and testing and the parameters. Does that help everyone get an idea? Okay, these terms, what you are entering into it, what all the things can be involved. Does that make sense? Does it make sense, Hari, Kiran? Does it give you an idea so that we don't miss anything?
Yeah, kind of a good intro.
Kiran, does that help you even to understand where you use statistics in this pipeline?
Yes, Srini, it does. But we will be covering NLP and image detection, right?
Okay, let me. I think I made it very clear. We haven't done that. This is the time. This is where we are.
Yeah, I understand. But then you mentioned that keep it for reference. So I'm not sure what to make of it.
Well, it's very simple. What I mean is don't break your head for this, and that is what I mean. Because you need to consolidate. See, suppose some people want to try for a job, they can consolidate the knowledge here, right? They can keep this as a reference, right?
Okay,
Suppose,
but,
it's very simple, Kiran. There is no but. It's very simple. You see, you want to, because you can't spend so much time on for everything. What I mean is, I will spend time on this, but if you start learning this, what if you forget this, Kiran?
So what Srini says is, Kiran, you have to choose where you want to
focus on.
Focus and start your career at. So you can start as a big data engineer or a machine learning engineer. That's where you focus and practice more. At the same time, you should know the concepts and working understanding of the other advanced things, like have a knowledge or understanding how it works, what it means for NLP or deep learning. What he's trying to say is, don't try to get expertise or a lot of focus and practice in the last two.
That's good. That's good, Harun. See, this is a message to overall people. If somebody has a lot of time, somebody has a lot of into, you sail with me. We are going to do this very deep. But what I'm saying is, if you don't become expert here and don't do your demos and presentations here, not practicing here, and spend too much on this, you are just good in everything, but not, you don't have expertise in this area. So when you go to an interviews, people select based on your thoroughness in this. People select you based on your basic understanding about this. You cannot say, I don't know much about this, but I know a lot about this. So, simply to put, Kiran, if you have time, become expert on everything. If you don't have much time, focus on these two areas for the job, for the career transition. But for knowledge sake, learn everything. So these two areas you need to consolidate till now. And this as a reference means as I speak to you, you learn Python, you learn TensorFlow, Keras, you learn natural language processing. So you learn it. Keep as a reference in the sense, oh, I know this how to do. You don't have to do too much hands-on. You don't have to practice that. But I will do that hands-on in the class. You will see it, but you don't have to every week spend so much time on it.
All right. Yeah, that sounds better now.
Okay.
Because I wasn't sure that if you were going to cover like code related to that. Okay.
No, not at all. It's very simple because now see, Narayan Rao is not doing job. He is trying for it. So he need to consolidate in these two areas. Or somebody don't have much time. It's they consolidate this. Or even strategically consolidate this, then you have time, then consolidate this. Then you have time, you consolidate this, become expert ever. That's how I go. But I think Harun explained you in a better way. Now I'm glad. Kiran, you understood, right?
Mm-hmm. Thank you.
Okay. So let me come here. Okay. So Hari, Kiran, now you understood, right, where this fits into the picture? Basic statistics?
Yes.
So this is where it fits into the picture. Good. Interestingly, this whole thing is even applicable to your deep learning and natural language processing. This process doesn't change at all. The process doesn't change at all. So as I told you, the agenda for today is our consolidation of the roadmap the next few weeks. I'll review this. Then after the break, I'm going to enter into the deep learning. Before I go to deep learning, I'm just highlighting the need of focus. What happens is, you all know, a lot of people don't practice. They come to the class, they go home. Once in the weekdays, there is no time. So again, we come to the class. So there is nothing wrong in it. That is how everyone is busy. So that is where I highlight for next 4 weeks, you guys will be focusing a lot on this. That is what the consolidation is. Then I and Arun will be focusing on this to help you. That is the idea. Okay. We are not leaving anything. We are not leaving anything. If anyone got any message, we are not leaving anything. Okay. In fact, we will even give you more than even you expect. Give me once. Okay.
Srini, just one question here.
Yeah.
IoT, when we are saying, are we doing something in that area or?
Yeah. See, IoT is a concept.
Yeah.
Concept. So I'll discuss a use cases. So
okay.
The area of focus is you get the data from IoTs into Kafka.
Right.
So Kafka, how you read from Kafka, if you know, you are very well doing the real-time data and the batch data. That's good. But what are the driving factors for it? We can talk about IoT. That is the idea. IoT means different devices connecting, the data flowing into it. So I want to highlight that. Okay.
Thank you.
Okay, very good. So let's go now. Let me come here. As I mentioned, these areas we are focusing it. These groups we have every one of you should participate. Okay. So tomorrow, Sairam, what are you presenting? Can you tell to the team? One minute. Sairam is on mute. It's okay. Sairam, it's okay. So anyway, I'll tell. So tomorrow, Sairam is going to present 30 minutes on a few functions and some data cleanup activity that we tried to do last session. So Harish Kishore Surya. So Harish is planning to present. Harish, right? You're getting ready for that? I'll guide you.
Yes, Srini. Yeah, I'll be doing it next week.
So recommendations coming Saturday or Sunday, I'll let you know. Sorry. So also get ready. There is another concept called market basket analysis. Usually that is a very peripheral topic, but it's a very interesting topic for the customers. So it appears like recommendations, but it's a very good topic. When you go to Amazon, when you buy a product, they will say customers purchase this product, also purchased these products together. So in the market basket, these products are purchased together. Okay. So Harish, get ready for next week. Then this will plan in the future. Hema and Leela, I'll talk what you are covering next week. So Hari Narayana, next week, in 2 weeks. Okay, get ready for that. This area, clustering area. Okay, so then what we are going to cover. So Kiran, Mukesh, Siva, you also have something? I'll tell what it is. Okay, what is being covered for next week? Okay, this is a use case I want to introduce. Sairam, Leela, and Hema, they are going to present this topic next week. What is this?
Just one question, Srini. On the WhatsApp group, Narayana is also part of it.
Yeah.
Okay, I could not see his number, so that's what I was wondering.
Okay, Narayana, okay, you can say hi in WhatsApp. Say hi, Hari. Okay. So this is one topic. Sairam, Hema, and Leela team is going to present. So what is this? This is a classification model. The topic is called customer churn. Customer churn means, Kiran and everyone, customer leaving your company. Say I'm an Apple customer. Say I changed my mind. Let me put it in this way. I'm a Samsung customer. I have bad service. I moved to Apple. So it means Samsung will have historical data who all the customers left their company, left their products. So they can study what patterns of the data is contributing to customer churn. That is called customer churn. So we have a sample data, a CSV file. It is available here, training data, test data. I'll be sharing with Hema Sairam team. So they will be using training data and testing data. So the data is like this. It is given in this way. In what state the customer is, their account length. They don't share the account. Certain masking is done. Account length and which area code. These are the telecom customers data. Whether they have international plan or not, voice plan or not, how many minutes they talk. Anyway, different features, 19 features. So almost up to here, 19 features. So this is a label. The true means they left the company. False means they didn't leave the company. So you have data, people who have not left, people who left samples. So we can do some data exploration, we can do some summary statistics also. We can do some mean of average, mean of some columns. We can take some sampling, stratified sampling. Stratified sampling means we already done that. Suppose there are so many rows of false. Since we want to find the customer churn, which is a true, so we should reduce the rows of these false samples. So you can reduce using stratified sampling. You have so many rows, put only 20% of these rows and some percentage of true rows. That way you have more sampling with true. But we also need some false so that we know the patterns. So these can be done here. So I'll work with our team. They will be presenting to you. Just giving a big picture so that they will, you are mentally ready what they are going to present next week. So Sairam, Hema, Leela, everyone. Typically it's a classification problem. So you want to train the model and learn the classification model so that you understand what customers' data is churning, in the sense who are the customers leaving, what are the patterns. So if you have that model, you can apply on the new customers so that you can identify this customer is at risk or not. Customer at risk of losing this customer, or the company is at the risk of losing the customer or not. So it's very simple for you. You're already doing. You have so much data columns. These are features, but ultimately you consolidate it to feature vectors. This is the label. This is the label. So your label and feature you'll be using for training. So that's where you get the models. So it's a classification model. Interestingly, classification, we have multiple models. We have logistic model of classification. You have decision trees and random forests. Interestingly, there is one more classification model called gradient boosted tree classifier. I'll talk about this. First, come here. The plan is Sairam will be doing. Sairam, please note this. You will be working on this data. You will be applying random forest on this algorithm, on this data to address this. That is, Sairam will be leading. So I'll tell what is this gradient boosted in a nutshell. Hema, this is an assignment for you. So you will be guiding Leela to do the gradient boosted tree classification. So Leela will be presenting it, but you will be guiding her offline. And when she present also, you will be moderator. You will be a moderator. Hema, do you get that idea?
Yes, sir.
Okay, Leela, so get ready. Okay. So it's very simple. So gradient boosted tree classifier means it is nothing but a random forest only. In random forest, the trees are randomly selected tree 1, tree 2, tree 3. Gradient boosted tree also look like random forests, but see this plus. See this plus. See, in random forest, there is no relation between this tree and this tree, this tree. Gradient boosted, this word gradient boosted. What it does is, you will have one tree, you will have one random forest tree, but when you have a second random forest tree, this tree takes some knowledge from this tree. Knowledge in the sense, say, this tree has some errors. See, every tree is a decision tree. Hema, every tree is a decision tree, you know. Each decision tree has some accuracy on the data. So this decision tree has some accuracy when you apply on the data. So when a second tree is built, so what it does is it checks the accuracy and it learns from that accuracy. Learns from that accuracy means it learns from the errors. So when it is building the tree, so this algorithm learns from these errors and corrects those errors in this tree building. How it does? It is a black box. It is a math behind it. It is those libraries will do for you. The libraries will do for you. So a second tree is built. When you're building a third tree, it learns from this. So it learns from these two. It is like a learning from these mistakes. But again, these decision trees. So this is a decision tree, this is a decision tree, this is a decision tree. It looks like a random forest, but those are gradient boosted tree classifiers. Gradient boosted tree classifiers. Yeah.
It is on the same data that you are going to have this different set of trials, or is it on different data?
No, they are going to do on the same data. Oh, you mean to say?
Yeah, from one to the second. Yeah.
No. See, in random forest, it's a subset of data, right?
No, the gradient boosted. Yeah.
Gradient boosted also, this is on different data only. Different data only.
Okay.
Some decisions may be different also, but what happens is there may be some common decisions, Hari.
Okay.
Because they are not totally different, right? It's only a random.
Right.
It's only a random. So even you have this one, we say I took this is random, right? The Mukesh Siva Kiran. This is grouping. Random, this is because you are in India. Some patterns are there. Right. So, but again, you guys are doing anomaly detection. That does not mean you cannot do this, right?
Correct.
So there are some common patterns between these two, but at the same time they are different, right?
Right.
So like that, they are in different subsets definitely. Just like this is a one subset. This tree is built. The second set, next tree is built. Next tree is built. What happens is it improves. It learns from some mistakes from this.
So yeah, that is what I was wondering. When you say learn and correct the mistakes, then are you taking from the same, sample data? For example, like what I'm saying is like, is it the same set of data? Like you're taking like say 1 to 1,000 the rows, for example, and then 1,000, 2,000 in the next. Is that the way, or is it like?
No, Hari is asking if it will be repeated. Sorry, can you ask the question again, Hari?
Yeah, what I'm asking is, like, in the first iteration, you take, for example, the n rows, and say it's like 1,000. And in the second iteration, you are taking the next 1,000 rows. So, if the data sampling may be giving a different output to the same, if you have the same logic. So that is what I'm asking. Is it going on like that? So you are boosting based on the same data, like, that's what
No, not same data, Hari. See,
same data in the sense, not the same rows, but a set of subset of the same.
we're talking about subset. See,
Yeah.
say you have one subset of data, so decisions are made. This is a second subset. You have a decision tree. Your third subset, decision tree. Here there is no relation. These decisions, randomly formed. So here what happens is, in this subset, so you have a decision tree.
Yeah. Okay.
When the second subset is formed, it learns from this. What is the accuracy of this decision tree?
Okay.
So wherever there are errors, those decisions, it treats as some impurity. Impurity is there in those decisions. So that is where it does some additional decision checks. So this tree is formed on a different subset. So it is like you started a company, you made some mistakes. Those are different company. But when you start a new company, you won't make those same mistakes here. Get it? So it is on a different data sampling. See here, this is a data. This is one subset of data, right?
Right.
This is a new subset of data. But when in the new subset of data, a new tree is building, these mistakes are taken care as much possible.
Okay.
Does that make sense? Not on this. So see, some impurity always there. See, if you go and just try to improve, there is no baseline. See, you cannot say I screwed up in some company. Let me improve that company. How much you improve? You improved, but still it failed, right? It failed in the sense it has some issues. You cannot improve this tree anymore because the tree has a lot of nodes. It's already formed. So when you are forming another tree, you can take those lessons here to form a different tree, because you are starting from beginning, right, Hari?
Yeah.
When you're starting from beginning here, these lessons can be applied here.
True, Srini, but what I am a little bit confused still is because see, the subsets are different. So that is where my confusion is.
That is what, Hari, to think simply, the subsets are different, but at the same time, they're not totally different.
Yeah, okay.
If I go to Kerala, there may be some differences in Trivandrum and North, etc. There may be some differences. But in a broad sense, my samplings, there'll be a lot of commonality, right?
Correct.
That is the idea. The decision trees are randomly chosen. Even why we are not using one decision tree? If you choose randomly, it will be very effective.
So in a broad sense, if I say you are trying to remove the mistakes in the data over the when you go over the gradient, like in a gradient, you are removing the mistakes one by one.
That is correct. This is also a random forest, but see, gradient boosted. You are boosting it. Okay, we have some issues here. So you start from beginning again. When it is doing it, when the decision trees are made, certain impurity, you might have a additional nodes, additional branches. You need to see how that algorithm does, inside. So that is the theoretical foundations. When they build those libraries, they do it. So you have a decision tree, you have a decision tree, you have a decision tree. It's just a matter of it learns from here, it learns from here, it learns from here.
Okay.
Then, you know, it even goes cyclically. It can come back. Okay, it might rebuild this also. It might rebuild. So it does in iterations. It does in multiple iterations. So that's why gradient boosted trees are even slower than this random forest. But it's a more effective, especially if the data is too big, it is effective. So to summarize, let's not get confused. It's a very good question Hari asked. So gradient boosted trees are nothing but random forest trees, but they learn from the previous trees. To building other trees, they learn from the previous trees. But for you as a applied machine learning person, you need to try to use those libraries. You need to know how to use those libraries. Okay, if you are interested to create those libraries, yes, you can join a 2-year course in machine learning in a university. They teach you how to the theoretical foundations in each algorithm, the math optimization techniques. Sometimes maybe a couple of algorithms may take a 3-4 semester course to learn behind the under the hood mathematics. So I encourage you not to worry about everything in the world. Please focus on your role. The role as applied machine learning people. It's good as a high level, you understand these trees. Just like Hari highlighted, they have a relation. But see this plus. When the tree is built, that's what it's called gradient boosted. It's a tree only. It's a random trees, random forest. That's why when you build this gradient model also, you will see number of trees. Let me show you quickly so that Hema can guide Leela. Let me.
Question, Srini.
Yeah.
In random forest, we see that the depth is always like equal for all the trees, but here will the depth be equal for the trees in gradient boost?
Interestingly, depth is equal. Depth doesn't change actually.
Okay.
Only the node parameters can change. Depth will not change. It's the same for it.
Okay.
I'm showing my desktop. Let me show you this. Can you see the browser, please?
You can see your screen, Srini.
We are seeing that customer churn screen.
PPT, yeah, the PPT we can see.
Okay, let me see.
Then you have to share the desktop here.
Oh, okay, good. Let me share my desktop. Sorry for that. Okay. Okay, let me quickly show you this so that you are aware what is coming, and it's not much difference. The process is the same. Random forest. This is a random forest, which our friend Leela has built last time. You might get the many trees. Let me go here. Okay. So Hema and everyone, please observe. For gradient boosted, you will be importing the gradient boosted classifier. So you will be building the that classifier. You need to set this particular thing. This is the new one. The difference between random forest doesn't have iterations. It only have number of trees and depth. It doesn't do iteratively. So this is one parameter. Rest all good. Set impurity, set maximum depth. Maximum depth is the main thing. This is not a really big deal, but play with it. You play with the ones, play with the Genie ones. So you just have a just like a classifier, general classifier, random forest classifier. Let me mute everyone. I see some background. Okay. So Hari, Kiran, Hema, everyone, please see. It's very simple, just like how you do for random forest. This is a GBT, gradient boosted tree classification model and classifier. You'll be building this GBT from this import, new GBT classifier. These two parameters are important. Okay, maximum depth and iterations. See, this is the difference. Then same model is, you build the model with the fit and the training data. You get the GBT model. You can use the evaluator. You have the predictions. You get the predictions. Pass these predictions to evaluators. That's it. Let me put it in. Emma, does it make sense? You have a GBT model. Leela, this is for you. GBT model, building, then you do the predictions, then find the evaluator to this evaluator object, find the accuracy, display the accuracy. This I have shown you without pipeline. You can build a pipeline and you can have a param grid, then you can display. Leela, Hema, any question on that? Hello, can you hear me?
Yeah, yes, Srini, we'll try to have a pipeline and the parameters.
Yeah, you can show this once,
okay.
And then you can put a pipeline also. Anyway, I'll speak to you offline. Sure. Hema will also guide you. Hema will moderate and you'll be presenting it. Sure. You'll be presenting gradient boosters. Okay. After Sairam presents the decision trees on the same data.
Okay.
On the same data. So I'll share all the information with you. So Sairam, is that clear? You have a customer churn data, your train and test data. You'll be converting them into label and features. Sairam will be presenting the same decision trees with random forests. Leela, with the support of Hema, will be presenting gradient boosted tree classifier. Sairam, Hema, Leela, does it give you idea what is our target plan for next week?
Yes, Srini.
Sairam, any question? Sairam.
Who's asking questions, Srini? Sairam is chatting. Is
okay.
random.
He's asking on the chat, I think.
Okay, let me see. I lost my. This one. Random can have iterations correct, not iterations parameter. It is not iterations actually. It uses the decisions at each level. Well, that iteration is different. Those iterations are for so Sairam asking a good question. In param grid, we use iterations. So those are the iterations in the sense iterations for the same depth. Here you see here. Let me show you. See, for same depth 6, this has iteration. Whereas let me show you the classifier, how you build the random forest. Give me 1 second. This is how you build the random forest. Sairam, can you please see this? This is a random forest, set impurity, set maximum depth, set number of trees, set some feature subset strategy, some set seed. Of course, these are not much important. See here, there is no, in the basic classifier, this is a classifier, this is gradient boosted tree. When you instantiate this, this has iterations, this has no iterations. These iterations here, the word iterations, please don't get confused. See here, iterations, since this is learning from this, going to this, and next tree from this, these are the iterations we are talking about. So iterations is a word, don't get confused. It can be used in a different context. Different context. So when you are doing it in parameter builder, let me come back here. In the parameter builder, since you are evaluating it, train with all parameters of the grid. Let me use this. This parameter builder, the term grid, the idea is to automate. You're testing it for multiple depths, etc. There also set number of folds, taking one training data, one testing data, one training data, another testing data. The English word iterations is correct here, but on what context you are using. So I want you to note that point. That's a good question, Sairam, you asked. Does it make sense now, Sairam? Kiran, any comment on this? Can you share your understanding on this, Kiran?
Yeah, I got it.
Very good. Kiran, does it make sense for you? Sairam asked a good question. Random forest also we are using iterations. He said now he understood. Kiran, you are on mute. Okay. Can't talk, that's okay. Okay, very good. Let's move forward. So that is good. So we know the agenda for next week. We are preparing our team. So that would give a lot of understanding. In between, here as we do, Hema and Lila, I want you to do some summary statistics. I'll work with you to show that. I know Sairam will be presenting random forest. As you do that, let him do the random forest. But we'll take whatever he has done, the feature building, etc. We'll leverage, we'll reuse what Sairam has done. But before we run the GBT, we will do some summary statistics. In the sense, some average, some sequels we'll run it. So that's good. Then sometimes, you know, the random forest might have more efficiency rather than a GBT. The expectation is gradient boost tree should have more efficiency than random forest. But in practice, when you do it, you might get a less one because of the sampling. GBT effect you will see only if you have a huge data. With huge data, it does effectively, does the corrections. Sometimes you have a data of 5,000 rows and 6,000 rows. You run random sampling and GBT. Sometimes random sampling might be, you might see 2-3% more than GBT. So that's where don't get confused. But general expectation is GBT should be more accurate, more efficient than random forest. Just for your information. Okay. Then give me 1 second. So I need to put few people on mute. Okay, then program for Harish and Harish. Harish is going to take up this recommendations. So he's going to brush up recommendations that we have done. So that way he's going to put foundation for the market basket analysis. So he's also going to do in the next week itself. So on Saturday and Sunday, we'll do Saturday and Sunday. So Sunday we'll do more time. This Sunday we'll do more time. On Saturday we'll do only half an hour or 45 minutes. This demo after Harun's presentation. So this Sunday, everyone will be presenting, like Hema, Siren team will be presenting. I'll be taking very less session on this coming Sunday. So next, Siva, Kiran, Mukesh. The same data, customer churn. The following week, not coming week, following week, you will be using logistic regression algorithm on the same data and see the classification. Come back. The linear logistic regression. So Mukesh, Siva, Kiran. So Siva and Kiran can start together. They can start presenting it. Then Mukesh can slowly join. But involve Mukesh also. Siva, do you get the idea what you need to do in 2 weeks?
Yes, Srini.
So can you highlight, can you summarize what you are going to do?
So basically the same data which the customer churn which is highlighted in the PPTs, we'll be using it and applying the regression
logistic regression
models. Yeah, logistic regression models.
Logistic regression also you'll use it for classification, right?
Yeah.
Exactly. So you'll be applying that. So they let them do that. Then we'll compare the results, accuracy. So in companies also, when you work, you may have a classification problem. You may be applying multiple models, a random forest on one thing, one time, the logistic regression one time, gradient boosted trees. Then you compare. Then you will decide which model to deploy. So depending on the data, depending upon the data size, depending on the number of features, depending upon the all these parameters, all this information. So these different models will have different efficiency. So though general expectation is GBT are more efficient than random forest, but depending on the size of the data, depending on the features, slight differences might happen. So you discuss with your team and decide what to deploy. But definitely the criteria will be, you'll try to deploy the more efficient system. Yeah, any question?
No, Srini. I think it would be more interesting when we take the same data and apply all these techniques and see how the outcomes are.
Very good, excellent, excellent, Siva. Siva, please take lead and try to involve Kiran and Mukesh.
Sure.
So it's a warm up for you guys. Then I'll give a very interesting stuff for you guys, challenging stuff also for you guys. But I'll give time. So you have 2 weeks time for you guys. Very good. Okay. before we take a break, any questions for the roadmap? Then slowly see what happens is once you do this, you get warm up. Harish team, Harish, please involve Kishore and Surya. So Surya is a little bit silent. Kishore is not attending the classes. Reach him, please. So Hema, Leela, Sairam already they initiated. Hari and DK. Sorry, DK may not participate.
DK is not participating. I already linked up with Narayana. He's not in our WhatsApp group, but I think we can add him. Not a problem.
I'll add him. Okay.
Yeah. So yeah.
Excellent, Hari. Initially start with clustering. So I'll have more good stuff for you. So all this exercise, guys, will give you a lot of good understanding to consolidate this knowledge. That is the whole idea, as Kiran has asked. So that I can focus on this, you can also focus on this. But first, top priorities are this. Consolidate this knowledge. Means to become expert on this and learn this. That is the idea. And next, so as you guys do this, and Harun and me will be helping you on how you link machine learning with real-time data. All other tools will be introducing to you, and we'll be focusing on this. We'll be training you on the deep learning and natural language processing. So that would be put you in a very good shape, guys. But again, without your involvement, participation in this, you cannot build this a good career. So this is a good foundation. And these are even built on top of these things. Harun, you want to share anything, any comments? As they do, as we are all going to support them?
No, Srini, I think this is a good, excellent approach to involve everybody, and slowly everybody will start feeling comfortable when they start presenting and getting hands-on like we did initially with the big data engineering last year or before that. So yeah, I'm just saying that that's a great approach to learning everybody. If they just participate, take it at their own pace, and start interacting with others and involve and practice, it'll become very easy just in a couple of weeks.
That is great, Harun. I truly value Harun's comment because he involved like that. When he is in the classes itself, almost he gave 10 to 12 sessions. So that would give him, more confidence, as he rightly said. So that's good. That's why we are teaming up, so that you don't feel alone and you don't get overwhelmed. Okay, excellent. So last, before we take a break, Harun, how are our team doing on the using Eclipse?
To be fair, I did not get feedback, Srini. I checked with Leela. She had some issues. I tried with the versions.
Okay.
Because the Java version.
Mm-hmm.
So after that, I'm also trying to see which version will work out, because on the VM, not able to upgrade the Java version.
Yes, Harun, I'm not able to upgrade Java version. So if I open the latest Eclipse version, it's showing that I need to have a latest Java version, but I downloaded, not able to upgrade because it's showing that you do not have permission.
No, is it specific to only Leela or?
I haven't received feedback from others. Maybe
tried only with Scala and Databricks. I have not tried with Eclipse yet.
Okay, no problem. So yeah, let's target 2 weeks time. In 2 weeks time, I want everyone. Now I know it's very comfortable to work on this here. Interestingly, even without Scala editor, these things can be run in the Spark Shell. So let's focus on Spark Shell. No, let's consolidate our practice on this. these should continue. When I say consolidate means gain more hands-on as you learn other things. That is the idea. Consolidation means gain what you call control on it. So how this now you see now Eclipse, a lot of people are not practicing. So this is the time to bring that also into the focus.
Yeah, that's what. Sorry, I missed that class on Eclipse, so I did not practice it. So I was wondering what is that is different in Eclipse that we are missing here. I'm not so clear on this.
Exactly. That's why let's not put. You don't have to worry. So I'm just putting a goals first of all. Next 2 weeks or next 3 to 4 weeks totally. So I want to. Harun is anyway taking leadership. I need help from Hema. Hema, we need help from you to help the team. So Siva, you also done a lot of stuff last year when we done the big data engineering classes. You helped our team on the Kafka and Flume and Zeppelin and few other aspects. So we need your leadership also. So I want you to collaborate with me, Harun. So we 4 should get ready to help our team. Are you open, Hema? And Hema is always, I think.
Yeah, Srinivas, next week I will work offline with Hema and look at the Eclipse version, Java and Eclipse, and I will get it done next week.
Very good. So there are 3 things. What are those? This Databricks, Spark Shell is always works.
Yeah.
Eclipse. This is an optional. I want to introduce to you another. There is a small editor called Atom. It is not a full-fledged editor like Eclipse. This you may, we'll try to, I'll talk to Harun and Hema and Siva. First we'll play with it and then introduce to you. So this you can use without VM on your local machines. Where the good thing about, before taking the break, let me spend a couple of minutes on this. Good thing about this is, say you have, you have a code like this, you can write it. And you can everyone see this?
Yeah.
Okay. If you see here, you can click this. You don't have to remember anything now. Just see here. So you can use this Spark Shell here itself, where you can run the Spark Shell. Of course, in Eclipse also you can do it. But so nowadays I see a lot of researchers, not only in the enterprise, in research areas also a lot of people are using it. So where you can write here something like whatever it is, whatever, something like this, defining add function. This is Spark Shell, basically everyone knows. But interestingly, here you can write the code. You can run this whole code in the Spark Shell itself. Here, this is the code. I want to run this code. Say I have a decision tree Scala. This decision tree uses MNIST, which our friend Hema has done. Here I have MNIST. All the decision tree, whatever you have here, you can sum it up and can run it in the Spark Shell. See here, it is running. Can everyone see this? We'll share how to do all those things, but just it's going to be interesting, as you see, you might do the corrections and you can put this code on the editor. So whatever you are doing one by one on the Databricks, you can always do in the Spark Shell one by one. It is doing line by line. It's doing a line by line. It is running the decision tree.scala as a script. So that would give you additional insight. So anyway, to summarize, what I'm telling you is Databricks, then Hema, Siva, Harun, and I will help you on the what do you call IDEs, these this one, and what is the other one? Eclipse. Then Spark shall also comfortably using it. So I want everyone in at least next 2 to 3 weeks, in 4 weeks, I want you to be comfortable using all these 4 tools comfortably. So that way you are in very good shape, guys. Okay. So Hema, Siva, how does it sound?
Sounds good, Srini.
Okay. Very good. So see here, it is running a CrossFit model. So seeing it on the shell, really it's good. The people who are working in a lot of Java environments like Hema and others, they might be using a lot of other tools. They're quite comfortable. So we should leverage their expertise. So this is the aim for next 4 weeks, but continue to work on the Databricks, but consolidate all our tools. Okay. Then we'll take a break. Then I'll introduce the deep learning, and I'll introduce the Python to you guys. So as we have these plans for the consolidation for the first 2 areas. Okay. So take a break, guys. It's 9:50. We are going to meet and 10:15, 15 minutes break. 10:05.
Thank you, sir.
Thank you. Okay, guys, welcome back. Let me see. Okay. 1 second, where is my... Okay. So Narendra, you're back. Harish, can you hear me?
Yes, Srini, we can hear you.
Okay. Very good, guys. Now you understood our roadmap to consolidate our knowledge till now. Consolidating your knowledge is very, very important. So now let's enter into the new area. So as we consolidate our knowledge with collaboration and making sure we are comfortable with all the tools, it's very important to learn this part of artificial intelligence, which is deep learning. See, many times you apply different algorithms to solve the problems at hand. You see the classification problem, you try to divide these data points like this. But what if you have a problem where the data points are like this? So you cannot divide it with straight line approximations. The straight line approximations doesn't work. Even if you see here, Siva, Kiran, Mukesh, you guys will be focusing on it. Excuse me. This is a logit function, or like a sigmoid function. It is trying to divide these 2 points with an approximation to a straight line. So this is also not complicated. Initially, we thought it is difficult, but now you learn, you are consolidating your knowledge on machine learning. At least you see, you started feeling comfortable, you will feeling more comfortable as you present. But there are some type of problems in enterprise, like images, recognizing images, or autonomous car, identifying the objects, or some data deals with sounds. So those data can be converted into text. That is not a big issue. We already seen when Hema explained about digits, MNIST digits. We know the images are converted to a text file. The conversion of images, some tools will be there, they scan and convert it. That is not an issue. But ultimately, you need to identify, you need to classify those digits. Hema used decision trees to identify the classification. Definitely, decision trees are very powerful tools, even compared to logistic regression. Because in decision tree, it's not a linear classification. It verifies a lot of decisions. But again, there could be more complicated cases where even decision trees will have a lot of challenges. So that is where the learning has to be deep. Learning has to be deep means you are building a systems that are learning very deeply. It means they have more intelligence, so that those systems can solve more problems, more complicated problems. So when the classification is very difficult, especially a scenario like this, you have red cells, green cells. So literally it is moving like this, it is moving like this, it is moving like this. Classification has to go like this. So lot of complicated learning. So to solve this deep learning problems, scientists historically, last 60 years, have been working on neural networks and support vector machines. There are two algorithms, support vector machines and neural networks. But over a period of time, they realized support vector machines cannot compete with neural networks. So that is where a field of deep learning has evolved, leveraging the neural networks algorithms. So neural networks is a kind of algorithms. Those are built, they are modeled after brain. So it's a mathematical modeling or computational models of a brain. Let me take back my words. It is not a computation model of a brain, rather it model after the brain. Oh, okay, brain, they studied the brain uses levels of learning, different levels of learning. And there are neurons, there are nodes, how the inputs are gathered together, how they are processed. So all these points are studied. All these points are studied and applied computationally, applied mathematically. They come out with neural networks. Neural networks. So it is one field. So deep learning means neural networks. There are no multiple algorithms. It's only one kind of algorithms. It is a neural networks. That's it. But interestingly, neural networks has evolved to solve even more deeper problems. So neural networks itself became a big field. It's like that's why it's called deep learning field. Deep learning. So we are going to discuss this. So I'll make you understand what are neural networks, what are the inputs, what are the outputs, how it does, the basic understanding. Then again, as an applied artificial intelligence consultant or engineer, you can use the standard libraries and follow the process you have followed for even the machine learning. That applies here also to solve certain types of problems. Okay. So what exactly is deep learning? As I mentioned, it is modeled after the brain. So if you see in a brain, these are the neurons. These neurons are connected to the node. This is a node. So different neurons are connected. So they reach to a node. So if you see a neural network, which is borrowed the ideas from the brain, there will be a node, okay? See here, there is a node. So these are the inputs. Imagine this is a neuron connection. Neuron connection. neuron connection, neuron connection, neuron connection. So you have 3, 2, 3, 6. Six of these inputs. 6 of these inputs are connected to this node. Just like this, look here. This is a node, brain node, brain neurons. Then rather what you call, these are the neurons. This is a node in the neuron. So it's connected. Here you see. See here, this is the node. So connections. So all this information come to a node. Then it get processed. And they maybe go out. See, they may be coming inside. These are inputs. They may be outputs. And they go to another neuron using the neural network. So, of course, I'm not, you can do some reading. There are dendrites, certain biological information will be there. I'm not discussing much. Certain other information will be there that you can read, or you can do some additional discussion. But directly I'm jumping to this. So see, you have inputs. These inputs can be pixels. X1, X2, X3, X4, X5, X6. But they can be even 28 into 28, 276 pixels. 274 pixels. So when they are connected to a node, so these are the connections. These are the connections. So these connections will have weights. These connections will have weights. I'll talk about that. But generally, see, hey, if this a typical neural network, a computational neural network, artificial neural network, will have inputs. These inputs. These are the outputs. We'll talk about this. See here, this is input. This is output. Harish, I might ask you a couple of questions. When I ask, you can unmute and please respond. Look here. Okay. This is the input, Hari. These inputs can be, the inputs are, let us take the case of image, they are pixels. Do you remember the last time I talked about the pixels? Let me show you that slide. Let me show you that slide quickly. I think 16th. These are the pixel grid. A move can be a rectangular, but imagine those pixels as horizontal. Hari? Yeah. Right? These are the inputs, right? 1, 2, 3, 4 grayscale images. Okay. Right. They can range from 0 to 25. Okay. Some people can normalize it in the sense, suppose 0 means 0 by 255 is also 0, right, Hari? Yes. Take as a probability. Suppose this value is 0. Okay. What is the probability? 0 by 255 is also 0, right? The pixel is 1. See, 1 by 255 is some fraction, right? Correct. 2 is the pixel, but 2 by 255 is some fraction, right? Yeah. How about if this is 255? What is its fraction value? 250 by 255, 1, right? 1, yeah. So it means these pixels can be represented between 0 and 1 also, right? Exactly. Either you can represent 0 to 255 or 0 to 1, right? Yeah. So it means you are comparing it to 255. Okay, so an image like this may have 284, 28 by 28 pixel grayscale, or if it is color, more pixels. Those pixels can be horizontally shown like this, and now each one imagine as input x1, x2, x3, like that, like that, like that. It goes.
Okay.
Okay. Let me mute. I think I see from background. You can mute. Okay. I'll ask you questions. Okay. So always in neural networks there will be input. Many times they are pixels. These are the inputs. So what is the expectancy? Expectancy is, hey, these pixels, these are the pixels. These are the outputs. So let us now understand the output. Kiran, Harish, what are the outputs? Output is, could be a number, right? So let me jump to a slide. Okay, let it come. So these are the inputs. These are the inputs. Say this is the number 9. Number 9. So it has a 784 pixels. Each one has its own value, like this. 28 by 28 pixels. Each one means 250 by 255. So each pixel is shown as a fractional value. So their value lies between 0 to 1. Harish, is that correct? Yes, we already talked. 0 to 1. So 1 means bright. 1 means bright. Then different, based on different grayscale. 0 means totally not a bright. In between there will be values between 0 and 1. So there will be 784 inputs. Harish, do we all agree on that? 784.
Yes, Srini.
Okay. Now Harish, same question to you, same. What is the expectancy of output in this network? Hey, you give this image, you should ultimately say either it is a 9 or 8 or 7 or 6 or like, is that correct?
That's correct. Yeah.
Classification. So classification. It's a classification problem. It's a multi-classification problem. If I give an image to this, I should be in a position to tell whether it is a 9 or 8 or 7. Right? So our outputs are 0 to 9, 10 classification in this problem. Is that correct, Harish?
Yeah, that's right, Srini.
Okay. Now see. Your input is fixed. When I brought an image, it doesn't change. That is fixed for that image, The output is, our expected is 9. Our expected is 9, but if it is 8, it means there is an error. If it is 7, it means there is an error. If it is 6, there is an error. If it is 5, there is an error. Okay. So if it is 6, we should somehow make the output to 9. That is what the intelligence or training means. Intelligence to our system or training means. Harish, is that a fair statement?
Exactly, Srini. That's right.
That is the idea. So then where is the control? Your input is fixed, output is expected. It means somewhere there should be control. These are the controls. These are the controls. The weights are the one where we have control. I'll tell you how we have control. Only there are 3 things. Inputs are fixed, outputs are expected. It is simple. It is like you go your home. You have your, sorry, excuse me. I have some small cough. Harish, you have an air conditioning unit. You turn the dial, right, to get the what temperature you want, what output you want.
Yeah.
So your control is the control meter, right? Control meter. Let's put one more example. Your input, you have power supply. Your power supply. You want a bulb should be lighter. You have a switch. Switch is your control, right?
Correct. Yeah, Srini.
You cannot increase the power. You cannot decrease the power, right? Because this is fixed. Your input power. The output, the bulb, or different bulbs are there. You want a bulb in bathroom or bulb in kitchen, bulb in whatever, wherever it is, bedroom. Then you use the right buttons, right?
Correct.
You want to have a two bulbs. You'll be using, two switches. So in neural networks also, there are only three things in a simple understanding. Everyone, please try to understand. This theory is very important. A lot of people really break their heads. I'm very confident I can simplify it for you, because that's how I understand. It is complicated, I cannot understand. I need to break it into simple points, then only I can understand. That's how I understand, that's how I learn. I want to share that simple understanding to you. Inputs are fixed, outputs are expected. The control is only on these connections. These connections are weights. Weight means what? Some value, some number, some numbers. So what does it mean? First is only, again I want to highlight, your inputs are fixed, outputs are expected, there are weights. Only three terminology. Then we'll build based on this terminology. Please see. Okay. Okay. See, in any neural networks, you have a node. These are inputs. This is the node. These are the values that are coming, or signals that are coming. When they come, each connection is identified with weights. Okay. So this is W1, this is W2, this is W3, these are the weights. Now everything is coming here. Here everything get added. When I say added, it is called weight multiplication input. Suppose this is A1 or X1, W2, A2, W3, A3. It is a weighted sum, So everyone, you understood inputs, output is expected. Now you understood the concept of weights. Any connections has a weight. As I told you the example, weight means, Harish, our connection weight is, we in the terms of time, we know each other. How long we know each other, Harish?
Yeah,
Maybe
last 6 years, Srini.
6 years. So our weight is 6 years. You take Kiran. Kiran, how long we know each other?
I think 16 years.
16 years? 2000.
15 years. 2003.
2003.
Yeah,
2003. You finished your master's and you came for ERP training. That's good. To the area from Mussoorie. Mussoorie, right?
Mm-hmm.
Yeah, I remember.
You do.
Okay, so our weight is 16. So that is what exactly the connection is. So some of the weights, weighted sum means the input value multiplied weight. I give you another example. Harish, say you go to a canteen, you go to a shop, you check out, or you go to a cafeteria, you're taking to go. Hey, you purchase a juice and its value some $10. You purchased, no, sorry, you took 2 juice. This is 2. A1 is 2. Each value $2. So what is this weighted sum? Just this one is 4, right? 2 into.
Yeah.
Next, another, you took 2 burgers. One for you, one for Saurya, your friend. So 2 is the burgers input. Its weight, each burger is $3. So 3 into 2, 6, right?
Yeah.
So this is 4, this is 6, like that, you know. So what you are buying is, and what is its price. So
Srini, can you go to slide 13?
Slide 13. Okay.
And the bottom you have an example, right? The picture of a panda and how we are supplying the weights to it and what's the output coming.
Yeah, we'll go to that. I'll talk. Huh? Yeah, I mean, it's the same thing. Yeah, if
I'm still having a little trouble understanding this. How we.
It is an old slide. I think. Yeah,
no, Hari, hold on. Let him complete his question. Sairam, can you please repeat the question?
No, I'm having trouble understanding this, how the weights are being given as inputs. How do we do it? I know you were saying weighted average, but can you repeat that weighted part again, weights part again?
Sure. First, that is what actually I'm building the blocks. Actually, we haven't come to conclusion yet. I'm building step by step.
I also, Srini, also have a similar question as Sriram. Sairam, sorry. So you mentioned that the output is expected. What do you mean by output expected? Like you already know that the image is going to be a panda?
What I mean is, if this is panda, that's a good question. Sairam, okay, this is panda. So inputs are pixels, right?
Mm-hmm.
So now, suppose these are the, say you are identifying the animals, assume. Say you assume you fixed there are 10 categories of animals. We have dogs, we have pandas, we have cats, we have some lions. You know, if you go to a zoo, there may be 10 categories of animals or 20 categories. Let me, can someone mute sing background? Okay, Sairam, let me show you this slide. Okay, so that's a good question, Kiran. You are asking a specific question to our building blocks. What is output is expected means it is panda. Say this is cat. This category is cat. This category is dog. This category is panda. This category is lion. So you expect this should rather this one, when you put this panda picture, this should be lighten up. Lighten up means imagine them as a light bulbs. Light bulbs. If you put this here, your panda bulb should be lighten. If you put lion, your lion bulb should be lighten. You put cat, cat bulb should be lighten. Is that the correct expectation? How we do it, don't worry. Kiran, now can you tell me, did you?
Yes, I understood. It's a classification problem. We already know that we have these categories and we have to classify them correctly, that this is a cat, a type of cat. So this is a cat, and this is a panda, or this is a lion. So I understand. Thanks.
That is good. Saira, this is inputs now. This should be the expectation. Where it should be is the expectation. So how neural networks does it, that is what we are going to analyze. For that, I'm building a step-by-step knowledge in our discussion. So these are inputs. This output is we expect this is how the classification should be. But how that happens? So third terminology is the weights. Weights means any connection between a node and inputs is a connection. The connection is a weight. The connection is a weight. How they build it? It's like a function. It's like a 5x. If I put it as a 5x, 5 is the weight, x is the input. So it's a simple mathematical function. It's a mathematical function. Okay. That's why I see it as an abstraction, logical understanding, first of all. Where it will be there, whether they put copper wire or gold wire, don't worry. Whether it is on server or how it is, that is a low level. They build the networks, they build the clusters, they build the cloud. All these things, somebody, Google or Facebook, they built. Otherwise, in Facebook, so many servers, how they are running. Even we don't know how they built it. So that is somebody's expertise. That's why go to a little bit abstraction. So connection between two nodes is called weight. Weight. So the weight is represented like this, please see. So when you say neural network, artificial neural network, it means that neuron, this is neuron, it has inputs, input node, it will have a connection. Connection 1, connection. This is a network. This is a simple network. One node, rest all inputs. It has weights. So this is a weighted sum. Weight input plus weight input, like a this is a juice, 2 juice, each value is $3, 6. This is a burger, 2 burgers, each burger is $4, 8, like that. It's a weighted sum, weighted sum. So at this node, you get the weighted sum, weighted sum, weighted sum. I introduced you what is weight, and I introduced you what is weighted sum. Sairam, at this time, you have any questions? I haven't completed how it does. I'm trying to building the blocks, building blocks, so that you are going to understand. Sairam, you're on mute. What is your question?
When you say the connection between the neuron and the node, connection between
You think as a node, 2 nodes also. Even this is also node. No, 2 nodes. Any 2 nodes. Because it happened to be these are input nodes. Okay.
Right.
2 nodes. Okay. Okay, Sarah?
And it is called weight.
It is called weight. Okay. It's like this is you and this is me. Our weight is, we know each other last 16 years. Right?
Yeah.
It's like, because our connection. Like
so we have 784 possible inputs.
Yeah, we'll go to that next step. First, after we understanding, hey, okay. Any node, this is a node, this is input node, nothing is coming to this input. This is starting, so this is starting. It's coming here. So when it comes here, you get a weighted sum. Yes or no?
Mm-hmm. Yeah, I understand that point.
Very good. Now you go. Now you go. Go here. Or let me even do this, or it is. Now imagine another node here, another node here. Let me come something like this. Sairam. Now see here, 1. So this will have weighted sum, 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 this will have weighted sum. Correct?
Only if it has connection with input node. Input.
Yeah, assume we have connection, you know, all the connections.
Okay.
Here also. So here there is, this is, so between input and output, there is one layer. So it is called hidden layer. Hidden layer means it is hiding between these two. Hidden layer. Now imagine there are more hidden layers. That's why it's called deep neural network. One layer, another layer. So what happens in this case, you please see. Saira? So you get a weighted sum here. You get weighted sum here. Weighted sum. These are some numbers, right? Again? Saira? You're on mute. These are some numbers, right? Again?
Yeah.
Now imagine these are the inputs to this now. Saira? Imagine these are the inputs to this layer now. That's it, right? See, if you take first 2, this is inputs to this. What is the difference between these 2 and these 2? I'm asking a question.
Difference between which one?
Okay, let me put it in this anyway. So let me, because you are silent when I asked this one. So that's where.
No, I'm thinking.
Yeah. So everyone, see, my suggestion is think very simple way. Don't think too much complicated. Don't think as a computer science. Don't think as even artificial neural networks. Just a simple. You see here. This is. Oh, sorry. Where is this? We all agreed. That's where. If you take one node, you get this weighted sum. This is a some number. Agree? If there are 2, see, everything is connected here. This is one number. This is one number. You all agree for this?
Yes.
Okay, now you go here. Okay, now you go ahead. Now you take these 2. Earlier you took these 2. All these inputs come here, 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 here. It's different weights. Different weights. Right?
Yeah.
These weights need not be the same as these weights. Look here. These are the weights for when we talk about one node. These are all inputs. All these inputs going to this. All these inputs to going to this. So like I see, assume these are all our class friends. And this is someone like Harun.
If the inputs are going to the 2 different nodes, or the weights is same on both nodes?
No, weights are different, right? No, it is like, see, this is Harun and this is me. See, Harun and your weight is last 1 year.
Oh, okay.
This is Srini and Sairam weight. This is Sairam. Sairam and Harun weight is different. Sairam, Srini weight is different.
Okay. Got it. Okay.
Excellent, guys. That's a good question, Sairam. So, but again, see, this has different weights, definitely. But this weighted sum, if you take, this is one number, right? This is one number. This is one number. See, the weights could be different, but weighted sum will be ultimately maybe different, but it is some number. Yes or no?
Correct.
Yes. So now we all know that is a good question. Sairam helped us to understand. Some people didn't ask question, but it's good Sairam asked the question. So the weights of these inputs with this node is different. There are 784 weights with one node. Another 784 with this node. Those 784 are different. These 784 weights are different. So the weighted sum of this node is a number. The weighted sum of this node is a number. These two numbers also different because the weights are different, because this sum for this and this sum for this is different. So these two numbers will be different. Sairam, do you agree with me?
Can you repeat the A1 part one more time? I understand the weights part, but that A1, A2 are the ones, the nodes? Or no, what are those?
Inputs.
Okay.
Inputs are pixels, right? Some numbers, right?
Okay. So the inputs and the weight. Okay.
See, inputs are some numbers. Weights are some numbers. Weight multiplied input.
Okay.
Let me go one more slide. I will come back here. Okay. Sairam, I think this makes sense. These are the input numbers, right? 0.5, 0.10.
Yeah.
Take this H1. H1 weights from this. H1 weights 1, 2, 3, right? H1 weights 1, this is 1, 0, minus 2.0, 2 point. H2 weights. H2 also will have 3 weights, right? H3 also will have 3 weights, right? 1, 2, 3. Is that correct? Sarah?
Yeah. So those weights are like constant. They won't change, like 1.0 minus 2.0.
No. Where you are going? Who said they don't change? For now, it is a weight. First, understand. See, what I'm trying to help you is understand building blocks.
No. I'm looking at the bottom box. H1 equal to sigmoid 0.5 multiplied by 1.0.
Before we jumping it, let's all agree one by one.
Okay.
Because otherwise it doesn't go anywhere. Because we need to build the blocks. Okay. So this is the weights. Whether weights will change or not, we'll see whether it makes sense or not, whether we change or not. They have to change, otherwise how we can control the output? They have to change. But before we change, first, what is the weighted sum? Let us understand. See, this is the weight. Everyone, please go slowly, guys. This is the weight. Now, what is weighted sum? Because since, Sairam, you asked me, what is A1, this one? Now we are discussing that actually. So, see here, 0.5 into 1, weighted sum, right? Comes. Next, minus 2.9. See here. Next, minus 3 to 2. See, this is the weighted sum. Don't worry about sigmoid. This is the weighted sum. You agree with me, everyone? For this. Sarah?
Suppose if I have like 4 inputs, then H1 weights would be like 4 different things.
Definitely, right?
Okay.
Whatever connected, everything is connected. Assume at this point, everything is connected to everything. Everything is connected to everything. This, we are taking one node. Just for one node, These are the inputs. These are the weights. Weight multiplied input is this. Weight multiplied input is this. Weight multiplied by input is this. Since everything is coming here, this is weighted sum. So if we take one node with inputs, I have weighted sum. Weighted sum. Input is a number, weight is a number. Input is a number, weight is a number. Weighted sum is also a number. This is a number. This is a number. If I take one node like this, if I take second node, everything is connected to that. But still it is a number. If I have many nodes, 3 nodes, take one. Take one. These are the weights. These are the inputs. Inputs are numbers. Weights are numbers. For this, weighted sum. For this, weighted sum. For this, weighted sum. What is this sum? If you multiply this and add, minus 1.9 is the number here. Number here is 3.1. Number here is 0.4. I just highlighted inputs are number, weights are number. If you take one node, this is a number. Second node, it's a number. Third node is a number. Is a number. But the number can be any value. Imagine how to normalize it. Normalize it. I want to make the number between 0 and 1 so that some normalization happens. How it can happen? How you can make it between 0 and 1? Take the simple example. When earlier you took even how you made the number, Sairam, Kiran, I told you the pixels can be 0 to 24 or 255. We can make it between 0 to 1. How? If I divide each number with 255, Sairam, don't it become all values between 0 and 1?
Yes. It's a 0 by 255, 1 by 255, up to 255 by 255.
So we are getting 0 and 1, right? Between 0 and 1?
Yes.
So that's how in neural networks, deep learning, they do normalization. Just because you do normalization, the patterns won't change. Patterns won't change. That's what practically observed. Okay. So how they do in the neural networks some normalization? So do you all agree, Sairam, Kiran, everyone? These are numbers. Depending upon the weights, depending upon the numbers, these numbers will change. Do you all agree? Those numbers can be minus 1.9, 3.1, minus 2.0.4, or it can be even 255, 355. It depends upon the weights and numbers. Numbers are weights. Weights are weights. The multiplied sum will be weights. Sorry, multiplied sum will be number. Those number can be any value. So imagine to normalize them between 0 and 1. We have a beautiful function called sigmoid function. If you pass those input, the sum into a sigmoid function, what will happen? You see, sigmoid of any number will always be between 0 and 1. Please see here. This is a sigmoid function, 1 by 1 plus e power minus t. This is x-axis, this is y-axis, this is t-axis, this is y. See here, Sairam, if t is 0, e power anything is 0, Sairam. 1 by 1 plus 0, so which is a 1. Sorry, 1 by e power 0 is 1. So Sairam, 1 by 1 plus 1, which is 1 by 2, its value is 0.5. Sairam, is that correct, Sairam? Sairam, you're on mute. Is that correct?
Yeah, yeah, correct.
Okay. So now increase key value to a lot of value, rather a positive infinite, increase it to infinite. E power minus infinite is 0. Anything to the power of minus infinite is 0. So this is 0. 1 by 1 is 1. So the maximum value is 1. So as this is increasing, it goes up 1. So from here, it goes to maximum 1. So now let's go this left side, Sairam. I think these things are very interesting to talk to your kids. They are studying 10th or 11th, 12th grade. Show them this function, or your cousins or anyone studying high school. Sairam, again, I'm giving a t as a negative value now. From 0, I'm moving to left side, okay? Minus 6, minus 10, minus 10, minus infinity, minus infinity. So e power minus of minus infinitive is e power infinitive, because minus minus becomes plus, because we are going to negative. Negative of negative. This is already negative. Negative of negative is positive. Sairam, is that correct? E power infinite. Yes. E power infinite, anything to the power infinite is infinite. Yeah? Okay. 1 plus infinite is infinite. So 1 by infinite is 0. 1 by infinite is 0. So 1 by infinite 0 means this sigmoid function goes to 0 for any negative value. Any negative values, maximum.
Yeah, so basically I think we are trying to find a pattern for this data using the sigmoid function. Am I right, sir?
The sigmoid function only normalizing it. We don't want so much random numbers happens. H1 is 255, H3 is 1000, H4 is 10,000. Okay? Yeah. So these numbers increases a lot of computation. We want to reduce that computation without losing the patterns. Patterns are not losing. So imagine, hey, this H1 is 1000, H2 is 2000, H3 is minus 5000. Yeah. That can happen. But interestingly, if you pass that numbers into a simple function, sigmoid functions, it will give you some value always between 0 and 1.
Yeah, correct.
So you are just normalizing it again. You are simply, we have so many numbers, you are just normalizing the numbers, that's it. So it means, again, you have still, there is a number, it is still a number, it came out of weighted sum. It came out of weighted sum. When you pass it to a sigmoid function, you get the value between 0 and 1. But again, your lesson still remains the same. This is a number. Everyone. So again, come here. You have a neural network. Maybe I'll go to little bigger one. Now imagine here. You have inputs are numbers. Now this is a number, Sairam, and between 0 and 1. This is a number, weighted sum, 0 and 1, because when you did a weighted sum and pass it to a sigmoid function, you get a normalized number, between 0 and 1. You know, this is also 0 and 1 numbers only. You know, even the 784 pixels between 0 and 255, if you divide each value with 255, you get 0 and 1. Their values are 0 and 1s only. I mean, between 0 and 1. This is also between 0 and 1, 0 and between 0 and 1, 0. And these are all these values also, again, 0 and 1s. So the outputs for these inputs between those two layers, this is input, this is output assume, is 0 and 1s. Now come here. Now imagine again, you have another layer. Again same story. This, take this. These are connected. It has its own weights. These are different weights. These are different weights. These are different weights. These are different inputs. Now for this. Now this is node. Connect to it, connect to this, connect to this, connect to this. Again same story. Why you are making complicated? Hari, Sairam, why we should make complicated? Same story. These are the inputs, numbers. Weights are numbers. This is a node. Pass it a sigmoid function. Get a value between 0 and 1. 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 0 and 0 and 0 1. Yeah. Agree?
Agree.
Awesome. Now come here. Like that, layers will be there. Finally, you will reach. This is the final. Look here. Now take. These are the inputs. These are the weights. These are the weights. These are the nodes. These are the nodes. Weighted sum. Pass sigmoid function. You get value between 0 and 1. This you get value between 0 and 1. This you get value between 0 and 1. This you get between value and 0 and 1. This you get value between 0 and 1. Yes or no? These numbers are different. These numbers are, I'll talk about them. First, forget these numbers. These value, I'm talking about the weighted sums. Kiran, yes or no? You get the weighted sum between 0 and 1. 0 and 1. Yes or no?
Yes.
Correct? Correct.
Mm-hmm.
Same. We repeat it. Inputs, weights. These are the outputs. Inputs are 0 and 1. Some weights. You get value. Each of these values will be 0 and 1. Here also. 0 and 1, 0 and 1, 0 and 1. So each has some number. Let's put some value here. Let me. Okay. First one has some 0.2. Second one has 0.3. 0.4. 0.5. 0.6. Like that. Let me start with 0. Harish? Harish? You there?
Hey, Srini. Yeah, Srini.
Do you agree? Say assume some numbers, okay? Assume this is 0, 0.0. I'm talking about absolute value, number you get. Because we already agreed, right? Anything will be between 0 and 1 only, right?
Correct.
So 0.0, 0.1, 0.2, 0.3, 0.4. This is 0.9 assume, okay? Which has the highest probability? Imagine this is a probability now.
Mm-hmm.
Which has the highest probability? This one, right?
Yeah, 9 to 1, yeah, 0.9.
So this is the first node or 0th node, first node, second node. Assume there are bulbs there are physical bulbs are there. So assume we put a rule, the maximum number bulb should be glown, rest all should be dark. Which bulb will glow?
Yeah, Srini, so ninth one.
Exactly, this bulb will glow, right?
Yeah.
If they didn't go, suppose this is 0.7. This is 0.9. Which bulb will glow? 8th, right?
Yeah, correct, Srini.
So you put a number 9 here. This bulb glow. Does it mean there is error in the network or not? I put a number 9. Ask this neural network to recognize this 9. The bulb that is glown is 8. It means the system is telling it this is 8. Right?
Yeah.
Guys, everyone, I think people are getting confused. I think it's 11 o'clock, automatically your brain will be tough. But it's simple. I'm not telling complicated things. I'm just saying, if I put a image 9 here, if this bulb glow, it means the system is saying this is 8. If system is saying 8, this system has error or not? Yes or no?
Yeah, it has an error.
Error.
Yes.
If this is glown, system is right. There is no error. Correct?
Yeah.
Correct.
So one of that will have maximum probability. If you say 0.9 or something will have 0.91, something like that. Because the network is so big, they round it to even it could be that. Maybe only one of that will have highest value. Highest value. It means the highest value bulb glows. Bulb means I'm just giving an example, thinking that. Okay. So 9 becoming 9 means there is no error in this network. Suppose you put 9, this you got the highest value probability. It means there is an error in the network. So everyone at this point, I have mentioned this one. The inputs are numbers. The outputs are numbers between 0 and 1 because of the weights. Again, these outputs are between 0 and 1. There are here 10 nodes are there because we want to classify 10 numbers, 0 to 9. So each node will have some value. One of the node will have a highest value out of 0 and 1. That number is our output. That number is our classified output. Though these are all outputs, but in the outputs we took the maximum number. So this 9 will be, this is image. So your classification output is either 9 or 8 or 7 or 6 or 1 or 0. Yes or no? Any question at this moment? I need 5 more minutes. 5 more minutes before we conclude. Kiran, at this moment, on whatever I talk, does it make sense?
Yes, it does. No question. Yes.
Okay. Now move to next step. Okay. So that shows to you your network is either for that image either correct or wrong. Okay. Suppose I put a number 9. I got a 9. I put another 9 because these are handwritten digits. Kiran writes 9 in one way. Sairam writes 9 in one way. So you say you have 10 different 9s people written. So it recognized Kiran's 9 correctly. But when I put Sairam's 9, my output I got 8. This bulb glow. It means there is an error. I took Harish, I got correct. I took Hari, I got 4. It means there is an error. Okay. How to correct the error? If Hari gave a 9, I got an error. So tell me, Hari, where is your control? How you can change these numbers? These numbers can only be changed by adjusting the weights, yes or no? The only control is you have only 3 things I told you have input numbers. You don't have any control on it. They are fixed. Output is expected. I mean, expected means you are expecting something. So the only thing that are controlling is weights. Because of the weights only, these numbers are getting changed. Yes or no, Harish?
Yeah, Shani, it is driven by the input weights. Yeah.
Of course. Where is even thought? You don't have to even think in 1 second. You have inputs and output. These are fixed, A1, A2, A3, A4, AN. And you want a desired number here. I want this, I want this, I want this. You are saying I want this. You can get what you want only by changing the weights. Where is the confusion? Harish? Sairam, you agree with that point or not? This is the crux of the neural networks. Just 2 things, inputs and outputs. Inputs are fixed. When I say fixed, for that image it is fixed. For that image it is fixed. Output you want to control. What you have to do, tell me. Sairam, now you tell me, weights will be changed or not?
Yes, adjust the weights.
Adjust the weights. Will you adjust the weights when you get the correct number? No, right? Because it's already correct, right? Harish?
One more time. What did you ask?
No, if you get already a correct answer, if it is 9.
Yeah, then there is no need. Yeah.
Very good. So, okay, see here. For Harish, it's correct. You didn't adjust. Same 9 for Kiran. You didn't adjust. For Sairam wrote a 9. The system could not recognize, so you have to adjust. So for somebody, you adjusted. So for same 9, for say 10 images of 9, you are training the system. Don't you think for some you adjusted, for some you didn't adjust?
Yeah.
Some. So what is the average of each weight? There are many weights, right? Sairam, you adjusted. You adjusted this earlier. Now for Kiran you didn't adjust. For Hari you adjusted again. So every time it is changing, which is the correct weight? So you'll be taking the average of weight. Whenever it is changing, say first weight is 1. Second weight it is changed to 1.25. Third weight 1.5. Third time. Same weight. I'm taking only one weight. Let's take one weight. W1. 2.07. W1 itself changing, 2.2. W1 it is changing. Why it is changing? Because we are training it for multiple images, right, Sairam? Same 9, Sairam 9, Kiran 9, Harish 9. For the same digit 9, we are getting multiple weights for the W1, isn't it?
Yeah.
Yes. Yes. So take the average of it. Take the average of it. Okay. So your training means what? Your training means for the known images, you are adjusting the, here these are 784, these are 16. So 784 into 16 weights. Then again one more 16. 16 into 16 weights. Next these are 10. 10 into 16 weights. This many weights you can adjust. Of course, some bias means, don't worry about bias now. So imagine these 1302, including few biases. Biases means some adjustment without weights. You can put some, introduce some numbers. But okay, I'll talk next class. So imagine 13,000 in this network, 4-layer network. These 13,000 weights can be adjusted. So it is simple. What I mean is, for each image, you are training and adjusting. Imagine you have a training data, you have 60,000 images. 60,000 images of the 0 to 9. You trained it. Finally, you adjusted it. You moved this side, that side, this side, that side, this side, this side. Finally, hey, I think, yeah, this is how it should be. This is how it should be. It's something like this. See, you come here to United States, you joined a university, then for training, you moved to a different state, you got trained, and you went to one client, you worked some time, you moved to some other place. You don't want to be a moving thing. Okay, somewhere, hey, I need to settle down. Okay, yeah, I buy a house. Or, okay, I want to live in New Jersey, or I want to live in North Carolina. Even if I have to change my job, I will travel from here. Something like that. You finally nailed it down. In the same way, for these all the images, after training, whenever there is an error, you changed it. Whenever there is an error, you changed it. The average of all changes. Finally, you have a network that is learned, which can read inputs, which can recognize the image into, which can categorize into correct output with a learned weights. Learning, see, finding the right weights and biases. Biases means some additional adjustment. Additional adjustments. You remember when in the olden days, when you are weighing some vegetables, they have weights, but the weight is not, they don't have accurate weight, they put some coins or some small stones. Anyway, let me not go that much. Finally, what I am saying is, whenever you say a neural network, it will be like this. You are training a neural networks means, for all the images, 60,000 images, for these layers, 4 layers, 5 layers, that is a hyperparameters. Assume we have now 2 hidden layers, 1 input layer, 1 output layer. The output is a classification, 0 to 9. You adjusted, training means adjusted. Finally, you have a right weights and biases. These weights are such that you put any number. If you put 9, it will show 9. It will put 8, it will put 8. Show 7, so 7 here. The training is done. Of course, there could be some errors. 90% of accuracy or 92% of accuracy, 95% accuracy. It means if you 100 images, 95 images classified correct. So your neural networks has input layers, output layers, hidden layers, and the weights. When you say I'm training my neural networks, training, it learned the weights. It learned the right weights. Now you have right weights. Give any input, it will classify. It will classify correct. It will classify correct. So that is what exactly the whole idea is of neural network. So simply to put, it takes the inputs. Since it has a learned weights, this goes to here, this goes to here, this goes to finally, yeah, it goes to the right bulb, right bulb. Right bulb will be maximum. That will go. Question. Sairam, it may be a little bit confusing, but still we can open for the discussion, but still just observe. Only 3 points. Inputs and outputs and weights.
Yeah, I understand the most of it, but do I need to know anything about the translation? Because if you look at the output, it's between 0 and...
What is your question? What is the translator you said?
The outputs are always between 0 and 1, right?
In this case, these are image recognition, right? If it is a,
image recognition.
If it is a, in this case, if the is autonomous cars on the roads, they should identify whether it is a car, whether it is a vehicle, human being first, vehicle or human being, 2 categories. Next, it is a signal, red signal or green signal or the light. Those are 3 categories.
Suppose if I have a picture of a car, so the outputs would be different. It could be more not necessarily between 0 and 1, or is it always 0 and 1?
No, the value is always 0 and 1, but the classification is you have 4 categories. These are 0 and 9 is the 9 categories. But these are the numbers.
Because these are for numbers, it's 0 and 9. For cars, it could be different. Okay.
If you have see here panda, you have only 4. If we want to recognize panda, lions, cats, and dogs. That's it. So your problem will decide. If it is autonomous car, maybe pedestrians. Tell me, Sairam, okay, 4 categories. If you are driving onto the road, what are the categories? Not which country these people are, etc. People is 1 category, right? What is the second category? Vehicles.
Yeah.
What is
speed bumps.
Speed bumps. Bumps means okay. Objects. Okay, let's put objects. Okay, objects.
And the traffic light.
Traffic light. Anything else? Let's put animals. Okay.
Okay.
Anything else? That's it.
So that's how you classify. Okay.
Yeah. So the problem is we have that's it. Human beings, pedestrians, vehicles, traffic signals, some emergency vehicles, some 3, 4 categories.
Okay.
So then anything a car sees it. If you can see a car or truck, whatever it is, it knows it is an object. It is, it is a vehicle. It is a vehicle. It sees some speed bump or some boulder or something. Hey, it is an object, the non-vehicle object. Human beings, animals, etc. They have different pixels, right? What are the weights? Even the inputs are different. The vehicles will have different pixels. Human beings and animals will have different pixels. Those pixels. The weights are adjusted. The network adjusts these weights when they train it. Initially, see, they might put a runs random weights. You may ask me how they know the weights. Put some numbers. See, I told you, right? Put some numbers. If you put the 9, you get the 0. This one. Then you can adjust it, right?
Yeah. So it's not like specific weight.
Now I put 5. Then after you adjust, it becomes 6, right?
Mm.
So that is where the network training, it trains iteratively, hours and hours. The training will be done. So these are the inputs. This is the outputs. That's why I go with building blocks, right, everyone. A lot of people don't understand this actually. Go and check with this. Forget about in one class. The people who attend 4 or 5 classes still don't understand. So I want to encourage you, go with a simplified understanding. You have inputs, your outputs. Go layer by layer. Again, here you get some numbers only. But here we want this number only, not this number. It means this number means this should have more number. This should have less number. Where is the control? The control is only on the weights. Okay. Training means changing weights. Oh, there is an error. Change the weights. There is an error. Change the weights. Of course, there are some techniques how to change the weights. There are some algorithms. Oh, you should change. You shouldn't change. Some people they want to fix a problem. They create more problems actually. Change. Your change should be Sairam, do you remember FM radio in the 80s? Like Sri Lanka Broadcasting Corporation, not AM radios. Their signals are very sensitive. If you move this side, that side, it misses, right? You have to finally adjust. Then only you will hear the cricket score. At the time, not everyone has a TVs. We used to listen in the radio. Transistor. So if you adjust it, it says queen, it says, right? Remember?
Mm-hmm. Yeah.
You need to slowly adjust FM radio.
Tuning.
Tuning. Okay. Fine tuning. So whereas AM radios, you can easily capture that signals. Anyway, guys, we will be discussing this. So I'm just only introducing to you. I will talk more. Let the concept settle down. Anyway, because this is not a one-day thing, actually. If you understanding these neural networks is very important. People respect you. You can able to comfortably talk neural networks. People really respect you. Because though they're simple, but you need to slowly observe, slowly understand. I truly appreciate Saira. Very good questions you put. Kiran, Hari, Harish, everyone. Nice questions. Those are very genuine. We will again go through one by one. We can talk how this is connected, how this each weight is changing, next row is changing. But finally, what is basis, biases, etc. Then I'll share these diagrams. Different weights, different biases. I'll talk also biases. So ultimately, whatever you are training, whatever biases you are adding, are just adjustments so that you get your output. Even you go and see painting, you want to paint a picture. You paint and finally you do adjustments to get desired output. You take your car to someone, that guy says it's fixed. You are testing it, he says, hey, it is not fixed. He will adjust. Hari, you are in testing. A developers test and you test and you said there is a gap. You send it back. They will adjust it. It is also the same. You are using a different logic for this. You have inputs, and I said the output is expected is this, but we got this. There is a gap. So go there and train it again. Change the weights again. Bring it back. Oh, this is good. Okay. Oh, in another case, this is wrong. Adjust it, but even adjust also you're wrong. Again adjust it. Wrong. Finally, somewhere as you are training it, it will be correct, the iterations. So, but what you adjusted, the mechanic adjusted some engines, but here in the neural network, the adjustment only the weights. You have no control. Inputs are fixed. The outputs are fixed. I mean, in the sense we want this expected. The neuron weights, these are the weights. Of course, you can have different layers. The layers only helps you to fine tune. If you have very less layers, it will become like a FM radio. You adjust this side, you adjust this side, you adjust to fix one problem, you get another problem. You adjust to fix another problem, you get another problem. So your network is not optimized. You go into more layers, you can adjust here, adjust here, adjust. You have multiple what you call layers. You have good denomination. It is just like, you know, Indian government released 2,000 rupees. If you have a 500 also, the denominations will be easier. You imagine if you are just in the market only 2,000 and 1,000 is there. Now what will happen? Hari? Only 2,000 and 1,000 is there. Then 100 rupees are not there. Different denominations are not there. Tell me how the transactions can happen. So you need multiple denominations, right? When you have denominations, when you have layers, you can adjust them properly. The transaction smoothly happens. So, you know, guys, this is a great subject. This is a great subject. Trust me, the whole world is talking about it. Go to any universities, people are talking about this. They talk the same things. So we will continue. I will continue to give you more understanding. Try to consolidate this logic till now, whatever we discussed, so that we will have a more discussion. Any questions before winding up? Harish, does it make sense some extent?
Yeah, Shani, yeah, we are gradually able to relate.
I agree with you. It takes some time to settle down, but these are mind-blowing concepts. Kiran, are we doing good? We'll have an additional discussion coming sessions.
Yes, yes, Srini.
Siva, doing good?
Yes, Srini, we're doing really good.
Okay, excellent, guys. We will catch up. Okay, everyone?
Yes, friend. Thank you.
Yeah. Leela, Surya, Sairam, good questions. Narayan Rao, Hema, let's support the team. Harun, good job, we'll connect. Okay.
Okay.
Okay, guys, take care.
Good day.
Thanks, Srini.
Thank you, bye. Okay, Hari, bye.